It's a great pleasure for me to chair the second session of this meeting. And our first speaker is Gustavo Branco, and he will speak on vacuum induced CP violation. You have 15 minutes for your talk.
Okay.
You have 15 minutes for your talk, and I will warn you at 12 minutes by voice, or there'll be a lowest sounding chime. Okay?
Okay.
Please begin, Gustavo.
Okay, so I have written many transparencies, so I will not have time to go in detail to the through the equations and so on. So I will start by giving the main ideas of the talk, and these are the ones that are important, not so much the equations and so on. Okay, so first of all, I want to thank again Jorge, of course, for organizing this, and all the organizers this beautiful meeting. And I already said that it was a great pleasure to see how things are organized. And I already thanked him, but I want to share with you that I like very much Violeta Parra. So I really enjoy listening to her. So let me go now to second page. This is nothing. So what is the plan of the talk? I will start talking something that everyone knows, motivation for 2x double bonds, and then controlling, this is a crucial point, controlling scalar flavor change neutral currents through family symmetries. Because one of the problems of multi-Higgs is to have flavor change in neutral currents. This, you may think that this is very bad because, then you have to fine-tune things. It's not exactly true. In my point of view, this is actually something good because it's something that it's unavoidable unless you do natural flavor conservation. And if they are there, maybe they will give signs. And it's very important, it's not, I don't like models or ideas that cannot be tested, experimentally. And the scalar flavor change neutral currents, they may be discovered. So I will talk about the beginning was the Weinberg, Glashow-Weinberg principle of natural flavor conservation. Then if you don't do NFC, then the challenge is to have naturally suppressed scalar flavor change neutral currents. I will talk about that. And then I'll give some realistic 2 Higgs double bonds with spontaneous Cpa violation. That's what at the end. And give some phonological implications, study them, and some conclusions. So the crucial, most of the talk will be about how to suppress scalar flavor change in neutral currents. In other words, how not to obey to the principles of Glashow and Weinberg. I would say that the principle of natural flavor conservation was done for two things: gauge flavor change in neutral currents and scalar also flavor change in neutral currents. The gauge flavor change neutral current principle was already proved that it is, it's very likely that it's violated. Why? Because, as we know, one of the most beautiful solutions of neutrino masses is through the seesaw. Now, within seesaw, the simplest case of seesaw, you have necessarily violation of this principle because neutrino currents, neutral currents, violated. There are flavor changing neutral currents in the leptonic sector, essentially because the P-S matrix is necessarily non-unitary. The violation of unitary are very small, but this is a matter of principle. So my claim is that already at that level, the Glashow-Weinberg principle is violated. Okay. Then I'll be talking about other things. Let me now go to the next talk. So I can go quick here because with 2x double models, I'm saying that there are new source of Cpa violation. We know that we can a standard model cannot account for the barrenness symmetry of the universe. Possibility of spontaneous Cpa violation was done by TDD in 1973. It's very interesting. This is the same year that Kobayashi Masukawa proposed their model. There is also a possibility of solving the strong CP problem through Pepe-Chequin mechanism. SUSY needs 2x double model, and of course the importance of AAC in all this. Okay. Now, as I mentioned, in general, 2x doublet models have flavor change neutral colors in the gauge sector and also in the Higgs sector. And let me not talk much about that. The two I already said about this, the natural flavor conservation. This was at the time was a very important contribution. Glasser-Weinberg paper is beautiful paper. It's, I think, as far as I know, is the last paper that they wrote together. And at the time, there was an attempt of generalizing this principle by Gatto. Well, I already said that the dogma in the gauge sector is already violated by seesaw, and in the framework of vector-like quarks are something that cousins of right-handed neutrinos, because you can write a mass for the vector-like quark without invoking a Higgs, a bare mass. The same is true for right-handed neutrinos. In context of the standard model, you can write a bare mass for the Majorana mass for the right-handed neutrinos. So now we have done we have constructed models where there is a suppression of a scalar flavor change neutral currents, because they are proportional automatically as a result of a symmetry proportional to VCKM small elements. Okay, this we have tried to do it, and at the beginning we thought that was impossible. Okay, I will explain to you why. This is done with the collaboration with my good friends in Valencia, Botella and Nebot, and my colleague Margarita Guy Rebelo. Now, I will go, the notation, I will go rather quick. This is just trivial writing both. What is different is that the Higgs, phi 1, for example, gives a mass both to gives mass both phi 1 and phi 2 give mass to the quarks. Okay, this is not like in the standard model. That's why you have a flavor change neutral currents. Now, this is leptonic sector. I don't have to go through more. I do the expansion around the vacuum as usual. I go quick here to explain the main things, okay, in detail. Now it appears something very important, which is the appearance of new flavor matrices related to the Higgs. Now this H0 and R and so on. The H0 is the Higgs that was discovered, but R and I are the new Higgses that are still to be discovered. Then you have 4 flavor matrices, MD, MU, and N0D and 0U. The important point that we have shown is that it is possible to have models where N0 are only function of VCKM. This is an incredible thing. I will show you that at first sight, this should be impossible, okay? Okay, this is the exactly couplings that involve these new matrices ND and NU. And now you can see, just looking at these two formula, this not only it's not true in general, but it should be very difficult to make it things in such a way that ND and NU only depend on VCKM. You recall that VCKM is not UDL, is not UDR, is not UUL, is the difference between the rotations on the ups and the downs, okay? So how could this be function only of this difference between ups and downs in the left sector? How are we going to get rid of these matrices UD and UR? This will be very difficult. I would say almost impossible, right? That was our feeling. So in general, and as I said, depend on UD and DR, UUL, UUR, special dependence on DR. How are you going to get rid of this? Our initial aim was to prove that it is impossible to have ND and U only depend on VCKM. While looking for the proof, it's very ironical, while looking for the proof that this is impossible, we discovered solutions. These solutions are so-called BGL models, okay? They are very unique for the reasons that I will explain. So I will give you an example of BGL type model, which is, is giving giving some example, of the models of this type, I introduce a symmetry. I will not specify what is the value of tau. The important thing is that tau has to be different from tau is different from 0 or pi. Okay, it has to be different from 0 pi. So Z2 is not allowed, here. So the form, the shape of the matrices, this symmetry here, lead that, for example, tau 1, which is the coupling of the phi 1 to the downs, is just 2 lines, only gives mass to 2 lines of mass matrix, okay, of the down sector. And the second one only gives mass to the third line, okay? So you can turn things around, and instead of putting this one transforming non-trivially, you can put, instead of putting this one, you can put the down. So you get other types of models. So since you have to choose a line, you can see right away that there are 6 possibilities. Either you do this in the down sector or in the up sector, okay? And for each sector, you have 3 choices. This line here can be in this position, or in the second line, or in the third line. So there are 6 types of BGL models. You may say, well, you are playing with matrices, you should get many solutions. No, this is absolutely unique. What is unique? If you require that you can have twigs doublets, but the flavor, the structure of the couplings of the Higgses only depends on VCKM. If you want that, this is the unique solution. People have proved that rigorously. Some colleagues here in Lisbon. Okay, why is this so exciting? Because you see, I'm writing to you DS, the most dangerous couplings, K0, K0 bar mixing, and these are scalars. Now they are suppressed automatically, not by hand, automatically, because they are proportional to VTD and VTS. Now, those who are familiar with already this was mentioned in one of the previous talks, familiar with VCKM, VTD is very small. In terms of Wolfenstein parameter is lambda to the cube. VTS is lambda to the square. So you have each one of these vertices suppressed by lambda to the 5. So altogether, lambda to the 10th. If you do the arithmetic, you arrive to the conclusion that these fields R and I can even be very light, no problem, okay? This is the thing, and this comes out automatically, this situation. Explicitly, you have ND proportional to one part that it is diagonal, and then the other part, okay? Now, so this type of model was suggested in 1996, a long time ago, okay? And they have some of the features of something that appeared much later, which I'm sure that some of you, those who do particle physics, are familiar, which is minimum flavor violation, okay? So this was a concept introduced by Burras, Gambino, and the collaborators, D'Ambrosio, Giudici, Isidore, and Strumia, independently. And they say that, okay, that maybe you have new physics, but the flavor part only depends on VCKM, okay? We had done it before, in a model, but we didn't make the propaganda, so this was known as minimum flavor violation. But they didn't put, they didn't use any model, they didn't put any model, it's just an hypothesis. We have a specific model, okay? And this is a question that I already mentioned. Can one introduce other discrete symmetries leading to other models where the flavor change neutral currents are completely controlled by VCKM? And the answer is no. In the framework of 2x doublet models and with abelian symmetries, flavor change neutral currents, and if you require that flavor change neutral currents only depend on VCKM, BGL models are unique. This, was proved by Ferreira and Silva. You can see 2 of my colleagues in Lisbon some time ago. So you may ask, well, we are playing with the texture zeros. We all know that these are functions of, these depend on the weight basis. You may say, well,
Gustavo, you are at 14 minutes, please.
14, so how much more you have? I can't hear.
1 or 2 minutes.
Oh, okay, I have to rush. This was still, I was talking about BGL models, but BGL models are not enough to have spontaneous CP violation, okay? So I have to I have to ask, can one generalize BGL models in such a way that there are flavor change neutral currents both in the up and down sectors? And the answer is you can generalize, but no longer you have that feature that only depends on VCKM. There are some other parameters, okay? So this is the possibility of generalizing BGL models. I wrote here, see, the main idea is that instead of having these two like that, you have both, everything is filled with thing, and then here you have like that, okay? So it's very similar to BGL, but you have from, if gamma is equal to 0 and deltas are equal to 0, you get BGL type models, okay? What is the advantage is because in this type of models, you see, this is the structure, you see, if you put delta ij equal to 0, one obtains up type BGL model. If you put gamma ij equal to 0, you obtain a down type BGL model, okay? So let me now go to the, we should go to the conclusions. You see, now you have other parameters. You don't have only VCKM, which I put here V. You have also some matrix U, but it's not too many parameters because in practice, only thing that enters are these elements of the matrix U. Is only the third column, okay? So you can do all this. And the important thing I want to show you, very interesting, is that VCKM, you know, in this model is proportional to the matrix, or some part of the matrix, orthogonal part, the matrix that diagonalizes the ups and then the downs. Then in the middle we have this matrix, and it appears here the factor 2 theta. It just comes out of calculation. Now, if we had not obtained this 2 theta instead of theta, we would have done a mistake, because in the limit of 2 theta, if 2 theta, for example, is equal to pi, you know, theta is equal to pi over 2, then there is no Cpa violation, okay? That you can prove formally without any. So the fact that it is necessary to have this in order to have Cpa violation, it can be shown formally just for an analysis of the scalar potential, and we have done it, okay? Phonologic implications. Now we can obtain the correct CKM, reproduce the moduli of the first and second line, and obtain the value of gamma. Gamma is extremely important quantity, okay? Because gamma proves that VCKM is complex, okay? This, you know, it's because sometimes people think, okay, if since CKM is complex, forget about spontaneous. It has to be hard Cpa violation. Not true at all. You may have models where this complex CKM matrix is generated from the vacuum phase, okay? Now we have, let me go tell you some interesting new scalars. In this model, new scalars are necessarily lighter than 1 TeV. It's difficult for me now to explain why, but you can trust we have the very detailed model. The possibility of observing new physics like T going to HC, HU, and T going to HBS, all this will be crucial in the top factors. There are many, including the next program in CERN, and also X factors. You'll be able to study the Higgs going to BS and all that, okay? So now conclusions, so that I don't take too long time. It is possible to have a realistic 2x double model with spontaneous Cpa violation. We'll not go into the rest. The model predicts existence of scalars at 1 TeV. Origin of Cpa violation continues being an open fundamental question. From experiments, we know that VCKM is complex, you know, but what is the origin of this complexity? You know, it can arise, as in the Kobayashi-Mascara model, through complex Yukawa carbon. It can also arise from spontaneous broken from the vacuum. Now, last but not least, apart from this solution, there are many other possibilities. In particular, 2 very important possibilities were pointed out by Rabbi Muapata, who is going to speak soon, and Ogora Sanjanovic, to have spontaneous Cpa violation in context of left-right symmetric models. Models with vector-like quarks, another beautiful possibility was proposed to solve the strong Cp problem by N. Nelson and Steve Barr, and we have analyzed the minimum model of this type in collaboration with Luis Bento and Paulo Parada.
Gustavo, you're out of time now.
Yes. I'm going to finish. Hopefully, I finish at the end, okay? Hopefully, high luminosity at LHC FCC and all the fantastic program that CERN decided to go, that we have something to give to our grandchildren. I hope that to live until 110 so that I can, with the mind still working, that I can see the great things that are going to be done. Okay. Again, I thank you very much for inviting me.
Thank you, Gustavo. Let me clap for everybody. And are there any questions? I don't see any hands raised. Do we have any questions? No questions. So thank you, Gustavo. We will now.
Sorry, Claudio is there. Claudio.
Somehow his hand is not up here. Yes. Okay. Please, Claudio.
Yes. A simple question is that what processes should you study to I mean, you try to observe to study this scenario or mechanism.
Yes. Well, in general, the main message of my talk and my previous papers, is that we should not be afraid of level change in neutral currents. Okay. Therefore, the Higgs, we know very little about the Higgs at the moment. So we absolutely need, for other reasons, but also to test these models, a Higgs factory. Higgs factory is a fantastic possibility, which, as you know, there are many possibilities, but the CERN program includes the Higgs factory. It will not be the one with highest energy, but the one that creates lots of Higgses and so on. That is crucial, For all reasons, I think it is a very important thing to construct a Higgs factory. And fortunately, CERN will do it also. Apart from doing FCC with hadrons at 100 TeV, will also do the Higgs factory. But maybe there will be some other groups doing. I don't know. Japan, ILC was people thought that will be built also. That will be a great possibility.
Okay, thank you.